Okay, 381. All right, let's read. Compare 2/3 and 2/5. Rewrite the fractions so they have a common denominator using greater than, less than, or equal to compare. All right, does the denominator ever change?
No.
Never, ever changes. So I know that my denominator is going to stay, hold on. This is multiplication. The denominator only changes. We need to make sure we know that. We never, ever change the denominator only when we are adding and subtracting. It's got to be a rule. Okay? When adding and subtracting, never change denominator. The denominator. Never change the denominator. It stays the same. Only when adding and subtracting. Multiplication is a different rule. Okay? And it looks like in this problem, reading the question is that we are doing multiplying. So does multiplying mean the denominator is going to change? Yeah, it doesn't have to be the same on multiplying. Only adding and subtracting. Okay? So let's go back to the problem. I have 2/3 and I can see that somebody wrote that in for me. What do you think goes into this hole that no one has written for me yet? Marcus? 2/5. Okay?
Wow.
2/5. We're just filling that in.
2 equals 10.
2/5. Hold on. Oh, no. We're changing this.
Isn't that 5/5?
We're changing this. 2/5 is sitting right here. Sorry. 2/5 is right here. That's not what we need to do. We need to guess using backwards math. 2 times something equals this 10. Hank, stop answering all the questions. Tatum. 2 times 5 equals 10. Okay? Whatever I times the top by, I times the bottom by. Did we already play this game before we left?
Yeah.
Whatever I do to the top,
I do to the bottom.
whatever I do to the bottom,
I do to the top.
I times the top by 5. What do I times the bottom by?
5.
5. 3 times 5 is what, Ender? 15. Okay. I'm back to seeing what the math book wanted us to do. I have 2/5 and I'm making an equivalent fraction over here. I'm doing the bottom half of this problem next. Because I can see that this answer is right here. So I have to do some backwards math. What's the opposite of multiplying, Abby? Divide. Okay? So the opposite of multiplying is divide. What's the opposite of adding? Hadley, thank you. Okay, so 5 times something equals 15, but I can do some backwards math because the opposite of multiplying is to divide. 5 goes into 15 how many times, Levi? 5 goes into 15. Let's put our toolbox together. It's okay, we've been out of school a little bit. 5 with 10. 15. We found it. How many down? 1, 2, 3. Levi, let's try it again. 5 goes into 15 how many times? 3. So I put a 3 over here. 5 times 3 is 15. Whatever I do to the bottom,
I do to the top.
so smart. 2 times 3. Eli, what's 2 times 3? 6/15. Okay, then I just take this information and I double it and I put it down over here. And I take this information and I just write it again. I said double it, but I didn't mean multiply by 2. I meant just clone it. Okay. When I have the common denominator on the bottom, that means my bottom answer is the same number. Can you see that there's a 15 here and a 15 here?
Yup.
Show me with your thumbs. Can you see that there's a 15 on the bottom? That means it's a common denominator. Once you have a common denominator, I don't care about them anymore. I don't need to know about them because I know the number that I need to know about is the numerator. And which one is greater? 10 M&Ms or 6 M&Ms? Which one is more, Bella?
How about
10. So my little alligator wants to eat the number 10. Rah, 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 rah. Okay, so I know that 2/3 is greater than 2/5. Okay, and I am going to erase this because you guys are going to practice your model. And you're going to draw a model, and they have to be identical. So we're drawing, actually I'm going to draw the number line first because I like to draw my model right on top of the number line. That is better for you. A 0 and a 1. They have to be parallel, which means equal distance apart. Straight line, 0 to 1. And I'm looking at the first fraction, 2/3. I'm going to label 2/3 so we can find it here. What the denominator's 3. So I slice it up into thirds. I double check that I divided it right. 1, 2, 3. I know that they're going to need 2/3, so I know I'm going to box 2 parts of my number line. Okay? And another thing I can do is I can label my number line. Let's do the next one, 2/5. I have to slice that into 5. It's not even, so I have to, can't divide it starting from the middle. I check my work. 1, 2, 3. Abby, pick up your pencil. 5 parts. 1, if my denominator is 5, what is 1 whole worth? 5/5, right? Okay. So when I'm labeling my number line, I put a denominator. It's the same all the way. What's the next number after a 1, Caleb? Or after a 0, Caleb? What's after 0? It's a 1. What's after number 1? What's after that? What's the next one? And we're at 5/5, which is equal to 1 whole. And it says that they're going to eat 2 pieces. So I'm going to bar around 2 pieces. Can you see that which one is greater, the yellow or the green? So 2/3 is greater. This is me checking my work, so I put a check mark over here. I checked my work to make sure my answer was right. Good job.